Hi everyone, my name is Rojafari and I would like to welcome you to another video. In this video, we're going to continue learning about hierarchical clustering. In the previous video, we started this journey by learning the different types of hierarchical clustering, and at the same time, we did see some different linkage methods for specifically agglomerative hierarchical clustering. In this video, we are going to take our journey into the programming area of R language. Specifically, we are going to see how we could go about doing agglomerative clustering using R in the environment of R. And we're going to do that in a specific example that we have already used in the previous slides. Alright, so let's get the slide. Alright, so the structure of this video is going to be very simple. We're going to have a very simple recap on clustering, and then we are going to see an example and go into R and solve that example using hierarchical clustering, specifically agglomerative clustering. So we did talk about how clustering algorithm does not have a dependent attribute, and basically our goal here is to use an algorithmic approach. In this video, this algorithmic approach is going to be hierarchical clustering to see the inherent patterns among the data objects in the data sets. So what we mean by that inherent patterns for clusterings, what we are looking after is to find groups of data objects by these two specific criteria. First, the groups, the data objects within the group are very similar to one another, and the data objects that are not in this group are very different than the data objects in this group. So based on the similarity between the data objects, we want to find these groups. And when we do that, that's clustering. So let's go ahead and cluster the 122 countries that we have here based on the 9 happiness indices of 2019. I mean, the 2019 is not written here, but this is the data for 2019. So we want to see if there are meaningful and inherent clusters among different countries. So our data objects here are our countries. Alright, so this is what we want to do. Alright, so let's go to, alright, so here first we need to install 2 packages, and then after that we need to call those packages. Of course, the package cluster, the agglomerative hierarchical clustering is going to use this package, and we're going to use the BBMESC for the normalization of the data, something that is very important for clustering analysis as we have spoke about it. So we don't forget to set the working directory. So when we read our data, which is this data, R knows what we mean to read this data. So R knows that we want to read the data from this specific folder. So you have to go ahead and do that. If you have already forgotten, that's the first thing you need to do. Alright, so let's go ahead and run these first few lines, which basically install these packages and then call them. This might take a while, just around 10 seconds. And once you get to this message, you know that everything is set. So the data set that we have is World Health Organization report, which is already pre-processed for 2019. So you're going to have access to this data set. Of course, there is no pre-processing that you need to do, so you're going to have access to this one data set itself. So once you read the DF, you will see that the DF is 122 data objects, which are the countries, and it has 10 variables. But one thing that is happening here, the index for the DF is numbers. At the same time, we have an attribute here that could have been better for the purpose of index. So first we rename the rows. So row names, this is the function you use. It's written in a very specific way, and that's how you need to do this in R. Once you run this, what happens is your data frame becomes updated, and now the row names of the DF are going to be the name of the countries. And since we don't need the first column, so we update the DF like that. So if I were to look at DF, now the name of the countries are the index, which is way better for our purpose because we want to know our data objects. All right, so next step, of course, before doing any clustering analysis, we need to do standardization or normalization of our data. For clustering, normalization is a better approach than standardization. Standardization is when our focus of our analysis are on the standard deviation. If we were to do principal component analysis, PCA, then standardization may have been a better approach. I mean, at the end of the day, actually doing a standardization or normalization wouldn't make that much of a difference for a lot of the algorithmic ways of going about finding the patterns in the data. But specifically for hierarchical clustering, the smallest detail, the smallest change in the data will change the result. And that's one of the weaknesses of hierarchical clustering, as we discussed. So specifically, I want to normalize the data into the range 0 and 1. One of the functions that is used for R normally to go about normalization and standardization is the function scale. But the function scale does not normalize the data into the range between 0 and 1. So instead, I'm using the normalize function, which is part of the BBMISC package, right? So that's why I had to install this package. So I normalize the data and the range between 0 and 1, and then I have to calculate the distance between every data object, right? So this function was going to do is going to calculate the distance for every possible pair of the data objects. And the reason that is done is because the clustering algorithm needs to know the distance between all of the data objects so it can go about doing the clustering analysis. Therefore, we calculate that distance, and of course we're using the Euclidean method. So once I run this, now I have the D, and then this is the function that does the agglomerative clustering. I mean, it has a kind of a unique name, Agnes, but this is what R has for agglomerative clustering. So pay attention here. When I am using this function, I say D instead of the DF, and I'm saying that what I am inputting is the distance. So this is what that means. It means that I am putting the distance. And of course, here is the linkage method of the agglomerative clustering. Of course, this could have been, other methods: single, complete, centroid, average, or ward. These are all the possibilities that you could include here, but here we're just going with ward, which we discuss is basically the ones that has the capability to include, more complex metrics as far as seeing the quality of the data, quality of the clusters. But anyway, once we run this, it basically gives us an output based on what we have. It gives us, it sort of like tells if different data objects. So these are the data objects, all of the data objects, and it gives us the agglomerative coefficient, which is basically a metric that how well this agglomerative data is basically were created into the clusters. It's not a very telling metric. I mean, it's 94, must be good, but it's not a very telling metric. You don't want to rely on this as far as being able to say, oh, I have a good quality clustering. But anyway, then once you have this, you can go about plotting. So you basically say plot AW output, and AW here, I have I meant it to mean A as in agglomerative, W as in word, right? So if I had used divisive and I had used another linkage, perhaps I would have changed this name. I mean, if I put XYZ here, this would work too, but we want our code to have intuitiveness into that. So we click the plot, and then once you do that, for you to actually to be able to see the plot, you have to bring your cursor here and print enter, click enter, or press enter on your keyboard. The first plot is the banner plot, which is not showing here because we have too many data. But the second plot, if you put another, is going to give us the dendrogram, which we have already discussed what it is. So we cannot see it very well here, so we can export it. I am going to export it as an image, and I'm going to make this a little bit larger. This is the largest, so I can see the image. So once I click save, it's going to be saved in the same folder that I set in the beginning. So here is our dendrogram, and if you pay attention, the dendrogram is exactly the same as the one that we had seen in the previous video when we used word method. So let me go back to that. So here is the word method. That this is the same dendrogram. I had created this dendrogram using Python. So I use different environment and different modules, different packages. But since we are using the same method, also we have normalized the data in the same way. So that's very important. That's the reason I insisted on using that function normalize, because I had created this with normalized data set. I wanted this to be the same. While these two dendrograms are the same, in the first look, they might look a little bit different. For example, let me go back to the other one. For example, we see here Afghanistan is on the extreme left, and when we go to this dendrogram, we don't have Afghanistan on the extreme left. We've got Afghanistan on here, right? And then next to Afghanistan we had Rwanda, but then here we have Rwanda, but if we come here next to Afghanistan, we don't have Rwanda. But at the same time, they are actually next to one another, right? So because Afghanistan is very similar to Rwanda than the other ones, right? So while there are some differences as far as the presentation that these different modules or different environment have used to present the dendrogram, they're presenting the same output. And this is happening because, like I said, the designers of these packages have made separate different decisions where their decision wouldn't matter for the end result. It does matter for the visualization, but it does not matter for the output of the clustering. So let's go back to R. And once we see this, as we did in the PowerPoint, we could decide how many clusters we want. We do remember if we cut our data here, we would get to 7 meaningful clusters. So all we need to do next is to say, I want 7 clusters. But before doing that, let me talk about some other way you could have done this. Do you remember to create use the Agnes, we use D distance? We didn't have to do this, right? We didn't have to go about this. We could have just, after having normalized df, just do df here, but instead you have to specify this, which is the distance, as false. It would give us the same exact result. So just letting you know that this is another way you could go about this. So let me click enter. And this is the same result. I mean, you could check that on your own. But anyway, going back to number of clusters, we had seen we can have 7 meaningful clusters. We use that number 7 here, so it gives us the clusters. So these are the clusters. So let me actually read this here so you can see what this actually is giving out. Basically, it's telling that the first data object or the first country is a member of cluster 1, the second is cluster 2, the third is cluster 3, the fourth country is cluster 4, the fifth country is cluster 3, and so on and so forth. So that's what we have here. So what we can do here, we can add that. So this is basically a new column. Every data object now have a cluster. So it's basically a new column to our data frame. So we can sort of connect these two together with this function data frame and click view df, which is going to give us a really nice visualization here. And this has been added here. So these are clusters, and we could also use this filter function here to see different clusters. So for example, we can see the members of the second cluster. These are the members of the second cluster. We can do for all of them, right? So second cluster, let's do another one. We can do, for example, see the members of the fourth cluster, right? So on and so forth. These are the members of the fourth clusters. And that's one way to go about centroid analysis after we do clustering. But also, R can help us a little bit, more than just that. We could calculate the average values of each of the clusters. So, for example, this line of code calculates the average values for the clusters 1, right? So we've got for cluster 1 life ladder, the median is this value, the mean is this value, and so on and so forth. We could change this to any number and we would get that order. So this is what we would normally do to analyze the centroids or analyze different clusters and see what it is about these clusters that are different. We can also run this last line of code. So the R will calculate for us how many data objects are in each clusters, right? So we can see that in cluster 1 we've got 12, cluster 2 21, and so on and so forth. So alright, in this video we basically learned how we would go about doing hierarchical clustering, specifically agglomerative clustering in R. Like I said, you could change this value to single, complete, average, centroid, all of those linkage methods that we've seen to get different results here. Alright, until the next video.